Imagine a world without computers, smartphones, or even simple calculators. A world where technology as we know it today didn't even exist in people's imaginations. Now, travel back in time over 2,000 years ago to the bustling city of Alexandria in Egypt, a city full of life, commercial activity and cultural flourishing. In this ancient metropolis, a brilliant inventor named Heron created a machine that challenged the limits of his time, a mechanical calculator based on the power of 10. It was a time when science and technology were taking their first steps. This ingenious construction, known as Heron's decimal calculator, is proof of the limitless ingenuity of the human mind. It was a tool that showed how far ahead of his time Heron was. This video begins an exciting journey of exploring Heron's decimal calculator, delving into its complex mechanism, its historical significance, and its deep connection to the technology we rely on today. We'll see how ancient inventions influenced the course of history. Join us as we uncover the secrets of this ancient marvel and discover how its legacy continues to shape our modern world. Heron's story is a story of inspiration and innovation that resonates to this day. To understand the brilliance of Heron's decimal calculator, we first need to meet its creator. Heron of Alexandria was a genius who excelled in math, physics, and engineering. He lived during the Roman era, a time of great advancements in science and technology. Heron's genius was his ability to turn abstract mathematical ideas into real inventions. He wrote many books about mechanics, pneumatics, and automatons, showing his deep understanding of the natural world and his passion for pushing the boundaries of human knowledge. Among his many inventions was the aeolipile, a steam-powered device considered a precursor to the steam engine, and the first vending machine, which dispensed holy water when a coin was inserted. Heron's decimal calculator, while simple in appearance, hid a sophisticated mechanism inside its plain casing. Constructed from wood, bronze, and a complex system of gears and axles, this ancient calculator harnessed the power of the decimal system to perform basic arithmetic operations. The device consisted of a series of numbered discs, each representing a different place value in the decimal system. These discs were interconnected with complex gear systems that converted rotations into numerical calculations. By manipulating these discs, users could add, subtract, multiply, and divide numbers with remarkable accuracy. The real genius of Heron's decimal calculator wasn't just its complicated mechanics, but also its use of the decimal system. This system, based on the number 10 and its multiples, offered a groundbreaking new way to represent numbers. Unlike earlier number systems, which often relied on complicated symbols and rules, the decimal system used a simple and easy structure. Its 10 unique digits, from 0 to 9, could be combined to represent any number, no matter how big or small. This innovation laid the foundation for modern math and paved the way for the development of more advanced calculators. Section 5, Gears and Mechanisms, the Mechanics of Innovation. At the heart of Heron's decimal calculator was a collection of gears, axles, and levers, with each part working together perfectly to perform complex calculations. This intricate mechanism, a testament to Heron's mastery of engineering, showed the amazing power of gears to change movement into useful information. When a user turned a disc on the calculator, a matching gear inside the device would turn. This rotation would then be passed through a series of connected gears, effectively carrying number information from one part of the machine to another. By carefully adjusting the size and arrangement of these gears, Heron was able to create a machine capable of performing accurate mathematical operations. Section 6. Bridging the Millennia. Ancient ingenuity meets modern computers. Even though they are separated by over 2,000 years, Heron's decimal calculator and modern computers share a basic connection. They both rely on handling information to perform calculations. Heron's invention was one of the first attempts to automate the process of doing math. This shared principle highlights the timeless legacy of Heron's invention and its profound impact on the development of computer technology. His influence is clear in every modern device we use today. Just like Heron's calculator used gears and disks to represent numbers and perform operations, modern computers use electronic circuits and binary code to process information. The shift from mechanical to electronic systems marked a new era in technology. Both systems, despite their huge differences in complexity and scale, show the timeless human desire to develop tools that can expand our thinking abilities and unlock new areas of knowledge. This constant search for innovation is what keeps pushing us forward. Section 7. A Legacy of Inspiration, the Enduring Impact of Heron. Heron's decimal calculator, though lost to history for centuries, left a lasting mark on the world. Its rediscovery during the Renaissance sparked the imagination of inventors and mathematicians, inspiring them to explore new frontiers in mechanical calculation. Leonardo da Vinci, the quintessential Renaissance man, was said to be fascinated by Heron's work, incorporating similar mechanical principles into his own inventions. The legacy of Heron's decimal calculator is evident in the development of increasingly sophisticated calculators, culminating in the invention of the first mechanical calculators in the 17th century. Section 8. Echoes of the Past, from Alexandria to the Digital Age. The journey from Heron's decimal calculator to the smartphones in our pockets is proof of the continuous march of technological progress. Each innovation, inspired by those that came before, has pushed the boundaries of what's possible, leading us to the digital age we live in today. Heron's invention, although basic by today's standards, planted the seeds for the development of more complex calculators. From Gottfried Wilhelm Leibniz's stepped reckoner to Charles Babbage's analytical engine, each innovation built upon the foundations laid by those who came before, leading to the electronic computers that have revolutionized our world. Section 9. The Future of Ingenuity. Lessons from a bygone era. As we stand at the dawn of a new era of technological advancement, Heron's decimal calculator serves as a timely reminder of the power of human ingenuity. This ancient device created by Heron of Alexandria is an example of how simple ideas can lead to great innovations. It reminds us that even the most complex technologies have their roots in simple ideas, born from curiosity and the desire to understand the world around us. This curiosity is the driving force behind every great discovery and invention. Heron's legacy challenges us to embrace the spirit of innovation that burned brightly in ancient Alexandria. This city was a center of knowledge and creativity, where ideas flourished and inventions were born. It encourages us to look beyond the limits of the present and imagine a future where technology continues to empower us to explore, discover, and create. A future where the possibilities are limitless and the inventions of the past guide us. As we enter this uncharted territory, let us take with us the lessons of the past, remembering that the seeds of tomorrow's discoveries are often sown in the fertile ground of yesterday's ingenuity. The inventions of yesterday are the foundation for the innovations of tomorrow.